66 million years ago, dinosaurs dominated the Earth. These mighty creatures roamed the ancient continents for millions of years, unaware that their reign was nearing a cataclysmic end. A colossal asteroid, originating from the asteroid belt between Mars and Jupiter, was on a direct collision course with our planet. Upon impact, it left behind a massive crater, 115 miles wide and 12 miles deep. This collision unleashed an apocalyptic force that not only caused the extinction of the dinosaurs, but also nearly annihilated all life on Earth. Hello, and welcome to ZE. Please don't forget to subscribe and hit the bell icon. So, what if an asteroid of similar size and speed hit Earth today in the same location? We can speculate based on our current understanding of such asteroids and our technological capabilities to prevent or mitigate such a threat. Would humanity survive? Could we thwart this cosmic menace? Let's delve into the details of the asteroid that almost wiped out life 66 million years ago. The Chicxulub asteroid, estimated to be 6.5 miles in diameter, entered Earth's atmosphere at an astonishing 45,000 miles per hour. Its impact released an energy equivalent to about 100 teratons of TNT, comparable to 2 million tsar bombas detonating simultaneously. Experts believe the asteroid struck in the worst possible location, just off the coast of Mexico's Yucatan Peninsula. A different impact site might have resulted in a vastly different history of life on Earth. You might wonder if we could detect such a massive asteroid heading toward Earth. Disturbingly, astronomers have recently identified potentially thousands of these asteroids, some large enough to destroy cities or trigger mass extinction events. Moving unpredictably around the Sun, asteroids are elusive, dark objects that reflect very little light and can appear unexpectedly. Consider the solar system's first known interstellar visitor, the Oumuamua asteroid. This 400-meter-long, 360-foot wide rock was only spotted after it had already passed the Sun, reflecting a mere 10% of its light. Though smaller than Chicxulub, its sudden appearance was alarming. On its way out of the solar system, it passed within 15 million miles of Earth, traveling at 85,000 miles per hour. Cosmically speaking, this was a close call. Currently, no existing Earth-based telescopes can track or see planet-killer asteroids hiding behind the Sun, and our technology offers no reliable means to destroy or divert such a large space rock. If we detected a mountain-sized asteroid hurtling toward us, our options would be limited, and we would need to prepare quickly for impact. Imagine astronomers detect something unusual in the sky, a growing black spot against the Sun. It's identified as a giant asteroid, 6.5 miles in diameter, on a collision course with Earth, traveling at 45,000 miles per hour from a distance of 90 million miles. We would have about 83 days until impact. Governments would try to keep this secret to avoid mass panic, but it would only be a matter of time before the public found out. Global space programs would collaborate to devise a plan to destroy or redirect the asteroid. The idea of using a gravity tractor is dismissed due to time constraints. Redirecting a massive asteroid moving at such high speed with a spacecraft, like in the DART mission, seems impossible. Launching nuclear weapons at the asteroid is considered, but there's uncertainty about their effectiveness and the risk of breaking the rock into smaller, more destructive pieces. Public chaos ensues as news leaks, and the world descends into panic. Authorities struggle to maintain order as people stockpile supplies and seek shelter. High-ranking officials retreat to underground bunkers like the Cheyenne Mountain Complex. Highways are clogged with vehicles as people flee the impact zone. Civilization begins to collapse as the impact approaches. In the final hours before impact, the asteroid appears as a giant fireball in the sky. Entering the atmosphere at 12.2 miles per second, it generates an enormous air blast, creating shock waves and a deafening sonic boom that flattens forests and shatters windows for thousands of miles. Electromagnetic disturbances from the ionized air affect electronic equipment, and communication satellites are destroyed. plunging the world into silence. The asteroid crashes into Earth with unimaginable force, releasing energy equivalent to millions of 50-megaton nuclear bombs. Massive earthquakes, exceeding 11 on the Richter scale, are felt globally. These earthquakes trigger tsunamis, with waves up to 3 miles high, devastating coastal regions and sending 1-mile-high waves across the oceans. The impact ejects 25 trillion metric tons of molten material into the atmosphere, with some temperatures exceeding those of the sun's surface. Superheated winds, over 600 miles per hour, radiate outward, incinerating everything within a 1,000-mile radius. The atmosphere fills with dust and ash, blocking sunlight and plunging Earth into darkness. This nuclear winter effect drastically reduces global temperatures. Dust and sulfur create acid rain, affecting the entire planet. The blocked sunlight halts photosynthesis, killing plants and trees that survive the initial blast. Global wildfires increase atmospheric carbon dioxide, causing a greenhouse effect that melts remaining polar ice and submerges much of the planet. Humans above ground would face almost certain death. Survivors in underground shelters would endure food and water shortages. Supply chains would be broken, and livestock would perish from the harsh conditions. Many animal species would die from food chain disruptions. Humans would have to remain underground for months. Above ground, urban areas near the impact crater would resemble post-apocalyptic scenes. Buildings and infrastructure would be obliterated. Fires would rage through cities, turning them into infernos. Tsunamis would submerge coastal cities. The human toll would be immense, with most perishing from the impact, tsunamis, fires, or environmental changes. Survivors would face disease, food and water scarcity, and the psychological impact of the disaster. Community health centers and renewable energy sources would be crucial for survival. Despite the devastation, humanity's resilience and ingenuity could eventually lead to recovery. Indoor farming, renewable energy, and rebuilding infrastructure could help us overcome this catastrophe. The Chicxulub impact, the asteroid that struck Earth approximately 66 million years ago, is widely believed to have caused the mass extinction event that led to the demise of the dinosaurs. Measuring about 10 kilometers in diameter, this catastrophic event released energy equivalent to billions of atomic bombs, drastically altering the planet's climate and ecosystems. While humans did not exist during this time, contemplating whether modern society could survive such an event involves evaluating our current technological capabilities, societal structures, and global preparedness for natural disasters. Understanding the Chicxulub impact. The Chicxulub asteroid struck the Yucatan Peninsula in present-day Mexico, creating a crater over 150 kilometers wide. The immediate effects included intense heat, shock waves, and tsunamis, devastating life forms within a vast radius. The long-term consequences were even more severe. The impact released massive amounts of sulfur and other particles into the atmosphere, blocking sunlight and causing a nuclear winter effect. This led to a dramatic drop in temperatures and a collapse of photosynthesis, severely disrupting food chains and ecosystems. Modern technological capabilities. One of the critical factors determining our survival would be our advanced technology. Today, we have early warning systems and telescopic networks capable of detecting potential asteroid threats years, even decades, in advance. Organizations like NASA and ESA have programs specifically designed to monitor near-Earth objects, NEOs. The potential for deflecting an asteroid, such as the proposed kinetic impactor technique or the gravity tractor method, is under active research and development. These technologies aim to alter the course of an asteroid to prevent an impact. Societal structures and global preparedness. Modern society's complex and interconnected nature presents both advantages and challenges in surviving such an event. On one hand, global communication networks would allow for the rapid dissemination of information and coordination of emergency responses. International cooperation could facilitate resource sharing and support disaster-stricken areas. On the other hand, our dependence on global supply chains could exacerbate the challenges posed by disrupted climates and agricultural failures. Potential survival strategies. Surviving an event akin to the Chicxulub impact would necessitate comprehensive strategies encompassing immediate, short-term, and long-term actions. Immediate response: evacuating areas within the projected impact zone would be a priority. Establishing emergency shelters stocked with food, water, and medical supplies could mitigate the immediate human toll. Short-term adaptation: the expected climate disruption would require measures to protect agriculture and food production. Indoor farming, hydroponics, and aquaponics could provide alternatives to traditional agriculture. Preserving genetic diversity in seed banks and livestock would be crucial for rebuilding food sources. Long-term resilience: rebuilding infrastructure and ecosystems would be a prolonged process. Developing resilient agricultural practices, investing in renewable energy, and fostering international cooperation for resource distribution would be essential. Rehabilitating affected ecosystems and mitigating the long-term climatic effects would require concerted scientific and governmental efforts. Psychological and social considerations: the psychological impact of such a catastrophic event on humanity cannot be understated. Societal resilience would depend on maintaining social order and providing psychological support to affected populations. Ensuring transparent communication from authorities and fostering community solidarity would be vital in preventing panic and maintaining social cohesion. Now it's your turn to share your thoughts. Could humanity survive such an asteroid impact today? What would your plans be if you knew an asteroid was heading towards Earth? Share your comments below. Stay tuned for more, and thanks for watching.